All right, everybody, welcome to the video here for lesson number 9, the last lesson of the chapter. So in class, at the end of the period, we had some time to do a couple on-your-own questions. So if you follow along with me, you can get the answers to those here. So for the first one, it tells us that the length of one whole side here is 100, and then one piece of it is 36. So this other piece must be 64. So when I start to redraw my triangle, so I have my small triangle. My small triangle has a short leg of 36 and a long leg of x. My medium-sized triangle, the medium-sized triangle has a short leg of x and a long leg of 64. The big triangle, I just have the hypotenuse of 100 labeled, so that one's not going to be one that I'm going to use here. So what I could do here is I could do some comparisons. So I can compare 36 to x. That should be the same thing that x compares to 64 with. So if we make our proportion, I can say 36 over x is equal to x over 64. One thing that a couple of you asked me during class, when you were checking your proportions and such, you want to make sure that your x's are not on the same side. That just wouldn't have made sense. So if I cross multiply, I get x squared is equal to 2,304. Now notice in this question, it doesn't say simplest radical form or anything like that, and 36 and 64 individually are going to be perfect squares. So when I take the square root of 2,304, I should actually get a perfect square, okay? I believe it's 48, but let me just check it. It's 48. So we get an answer here for x of 48. For the next one, again, we could start making our triangles here, but one thing I notice is that this little segment is going to be 16. Not sure if I need that or not. So I could see the small triangle has a shorter leg of 9 and a hypotenuse of x. The medium-sized triangle has a longer leg of 16, and that's all that I have for that medium-sized triangle here. The big triangle has a shorter leg of x and a hypotenuse of 25. So I'm going to do some comparisons here between the two, the smallest triangle and the largest triangle. So I'm going to say x becomes 25, the same way that 9 becomes x. So if I start to set up my proportions here, I can say x over 25 is equal to 9 over x. Cross multiply, and I get x squared is equal to 225. Again, when I take my square root here, if I plug that right into my calculator, I get a perfect square of 15. Number 3, if I look at my medium and my small triangles, those are the ones I'm going to compare here. So the small triangle here, right, looks to have a shorter leg of 7 and a longer leg of x. The medium-sized triangle here already has the correct orientation, short leg x, long leg 9. The large triangle, I do know this segment here, all right, that segment 16, but that's the only side I have. So when I look at the large triangle, I just know the hypotenuse is 16, not really going to be helpful here. But what I can say is 7 becomes x. That should be at the same ratio that x becomes 9. Cross multiply, and I get x squared is equal to 63. Now, unfortunately, 63 is not a perfect square. So when I take the square root of this, I have this square root of 63, and I have to simplify that, which goes back to a lesson we did earlier in the chapter, and something that we had said was a math skill. So looking at this, I have 1, 4, 9, 16, 25, 36, and I'm looking for the largest number on that list that goes into 63 as a factor. The only number that actually works is 9. So I could change this to 9 times 7, and then we can say x is equal to 3 square roots of 7 is my final answer in simplest radical form. I guarantee you something like number 3 would be on your test this week for Unit 5. All right, moving right along. Looking at this next question. So the small triangle has a shorter leg of 36 and a hypotenuse of 60. The medium-sized triangle just has a longer leg of x. That's not going to be helpful. And the biggest triangle has a short leg of 60 and a hypotenuse of x plus 36. So I could say 36 becomes 60, the same way that 60 becomes x plus 36. Do some cross multiplying. 60 times 60 becomes 3600. 36 times x is 36x plus 36 times 36, because I'm going to distribute that. So if I do that in my calculator, because that I don't know, 1,296. Subtract 1,296 from both sides. So if I do 3,600 minus 1,296, I get 2,304 is equal to 36x. Divide that by 36, and I get x equals 64. All right, hopefully that helped. Moving on to your homework assignment. So it says in the diagram of triangle DEF, the altitude is drawn. It says DG is 8. DG is 8. And it says GE is 16. And then which would the following be for the length of FG? So I'm going to put X there since I don't know that. So looking at my separate triangles, small triangle has a short leg of 8, a long leg of X. Medium-sized triangle has a short leg of X and a long leg of 16. That's all I need. All right, if I put that in the right spot, because I have everything is compared now. So I could say 8 compares to X the same way that X compares to 16. Cross multiply, I have X squared is equal to 8 times 16, whatever that comes out to be. All right, so use your calculators here. 8 times 16, so that's 128. Not a perfect square, so I already know it's not choices 1 or 4. If I try and simplify the square root of 128, I'm looking for a perfect square that goes into 128. So 1, 4, 9, 16, 25, 36, etc. And if you keep typing these out, you're going to see 64 works. So 64 times 2, so x equals 8 square roots of 2. Notice that's not a choice because I have a typo here. All right, number 1 should have been 8 square roots of 2. All right, so moving on to number 2. Number 2 says, in the diagram below, segments are perpendicular. It says MP is 24, and it says QP is 6. So that would make QP 6. If I do 24 minus 6, I get 18 for MQ. Label everything you can. And then what's the segment of NP? So I don't know that, so that's X. So when I redraw my triangles here, so the medium size one, right, I'm going to have an X and a 6, right? Look at that NQP triangle. If I look at the small one, the small triangle, I just have 18. That's all I have for this small triangle. The big triangle, however, I have the hypotenuse is 24, and I have one of the legs, the long leg is X, so I could use those as my comparison. So I could say X becomes 24, same ratio that 6 becomes X, cross multiply. X squared is equal to 6 times 24. So that's 144. Square root both sides. I see 144 is a perfect square. So NP is 12. It then says, use the answer number 3 to determine the length of MN in simplest radical form. Now, even though this is asking us to find another segment in this triangle, if I just look at the big triangle here for a minute, I want to find this piece. I know this piece, and I now know this piece. Meaning, well, guess what? I could do Pythagorean theorem. So I could say x squared plus 12 squared is equal to 24 squared, right? Because if I use a squared plus b squared equals c squared. Remember, c is always the hypotenuse, the longest leg. So if I do some math here, I have x squared plus 144 is equal to 24 squared, which is 576. Subtract 144 from 576, and I get x squared is equal to 432. Square root that. 432 is not a perfect square. It's not on my perfect square list. So I have to try and find a number that goes into 432. So I have my 1, 4, 9, 16, 25, 36, 49, 64. This set of numbers, remember, you could get right on your calculator. You do not have to have this memorized. And we're going to keep going until we get about halfway, so somewhere around 200, all right, so that we make sure that we didn't miss any, and that should be plenty big. So the process for me simplifying this bigger number is I'm trying to divide 432 by the numbers on that list backwards until I get one that works. So if I try 225, it comes out to be a decimal. If I try 196, it's a decimal. 169, another decimal. But 144 works. So I could say x equals the square root of 144 times 3. But the square root of 144 is 12, so my answer is 12 square roots of 3. Number 4 says the altitude drawn to a hypotenuse of a right triangle EFG partitions it into two segments of lengths of 8 and 10. Find the length of the longer leg of triangle EFG in simplest radical form. This is explaining the same picture we've just seen over and over and over again. So if I draw a right triangle EFG, right? So we want to find the longer leg of EFG. I have a segment that partitions into two pieces of 8 and 10. So if I want to find the longer leg, I've made it so that my longer leg was x. Just from what my picture looks like there, right? So if we go through and start looking at our separate triangles, right? The small triangle, the medium-sized triangle, all these triangles have things labeled, and the largest triangle. So the largest triangle, I know the hypotenuse is 18, the longer leg is x. In the medium-sized triangle, I see the hypotenuse is x and the longer leg is 10. That's enough info for me. All right. In the smallest triangle, I just know the shortest leg is 8. That's going to be irrelevant info for me. So I could say x becomes 18, the same ratio that 10 becomes x. So I have x squared equals 180. Square root it. So I have x equals the square root of 180. Again, looking at this list, 1, 4, 9, 16, 25, 36, 49, 64, 81, 81, and then 100 already too big. So again, we're trying to find the largest number here that goes into 180, right? So this is one where, like, I know 9 goes into it, but the 9's not going to be the number that we want. It's not big enough. Right, so we got to try and find a bigger number, all right? So if we keep trying, we'll notice that 81 doesn't work, 64 doesn't work, 49 doesn't work, but 36 finally does. So I could say this is really the square root of 36 times 5, which becomes 6 square root of 5 for my final answer. Hopefully this video helps. Right, as you're going through and starting to study for your Unit 5 test, remember you can always look back at old videos just to see how you did things, right? Best of luck with your homework and starting to study.